Hello everyone, it's Mr. Miller here again with a review on how to multiply monomials. Unlike adding and subtracting, you do not require like terms in order to multiply and divide monomials. Here, we don't have like terms. We have 3c cubed times 5c squared. What I'd like to do though is think about this with a more concrete example. We're going to replace the c with 2's. Now we have 3 times 2 cubed multiplied by 5 times 2 squared. Since multiplication is commutative, I'm going to put my terms with 2's together and my other constants together. Now we've got 3 times 5, which gives us 15. 2 cubed gives us 8, and 2 squared gives us 4. If we multiply the 8 and the 4 together, we get 32 times 15. Now let's think back. We swapped 2 in for c, and 32 is the same thing as 2 raised to what power? It's the same thing as 2 raised to the 5th power. 2, 4, 8, 16, 32. Now, let's think back. We swapped in 2 for c. That means we could rewrite this problem as 15 times 2 to the 5th. And we could keep going. But I want to get back to our c, so let's swap our c back in for that base 2. We could think of our answer as 15 times c to the 5th. This makes a lot of sense when you consider what exponents mean. So let's go back to our original equation. We know that our answer is 15c to the 5th when we use numbers, but let's think about why this works with letters. Remember, exponents indicate repeated multiplication, so let's rewrite our variables in expanded form. Now we've got 3 times c times c times c multiplied by 5 times c. Again, multiplication is commutative, and we want to rearrange our constants together and our c's together to make this a little easier. So we have 3 times 5 multiplied by by c times c times c, which is the same thing as c cubed, multiplied by c times c. 3 times 5 is 15, and we have 5 c's multiplied together. Now, when we think about what the rules of exponents are, we realize that 5 c's multiplied together are the same thing as c to the 5th power. That's the same answer we got before, which is good. But let's break down what these calculations look like to solve from the beginning. We're going to start by multiplying our constants together, and you'll see that done right here. If there's no constant before the variable, you can assume the constant is 1. Now, because we're always going to group our constants together, you can feel free to multiply them right from the beginning. Next, we're going to add the exponents of like bases. Adding the exponents is the same thing as multiplying them together, because exponents signify repeated multiplication. Here's where we did that. Okay, let's try another one. 3 times x squared times 5xy to the 4th. We can simply add the exponents of our like bases again, right? Let's find out. When we rewrite our problems in expanded form, it looks like this. Again, we want to group our constants, so let's go ahead and do that. And we want to group our variables using the commutative property of multiplication. Once we've done that, it's easy to tell that we've really got 15c cubed times y to the 4th, which is exactly what we get by multiplying our constants together and then adding the exponents of like bases. Coming up are some practice problems. Get ready to pause your video and try them yourself. Here are some practice problems. I'll start counting down now. Here are your answers. Did you get them right? Did you remember to multiply your constants and then add the exponents of like bases? That's all for today. Don't forget you can call, email, iMessage for help, and as always, I hope to see you in our study hall session soon.